Okay, this is a lesson about Java and null pointer exceptions, what causes them, how to prevent them, and how to read them. So it's sort of a three-part section. First of all, we're going to quickly just go over how to, first of all, read them. So if you do get a null pointer exception, how do you know what is null in this null pointer exception? Obviously, you get a stack trace, and there's a null inside it. It's a null pointer exception, and you get a stack trace. So, what is null? I have discussed these rules with you before, so I'm just going to quickly glance over them again. And these are these three rules. Okay, but there's one exception. I'm going to repeat it twice, so it gets stuck in your head. Okay. These three rules only apply if the line number that it's on is the top line in your stack trace. Okay, so if you get a null pointer exception, it'll say null pointer exception at, and then there's a whole lot of places. It'll say this file, this line number, this file, this line number, this file, this line number. It only applies if it's the top line, if it's the top stack trace. Okay, the very first one you find. Okay, I'm just going to repeat it again because you guys make that mistake a lot. If there's a stack trace with a null pointer exception, the actual null pointer occurs at the top of the stack trace. So you only have to look at that one, then this applies. Okay, if the top of the stack trace is some Java library or somebody else's code, then you probably, not always, but probably passing that guy. You're calling a method that somebody else wrote or a native Java method, and you're passing it a null. So obviously then you might need to go down the stack trace and find your, wherever you coded, and see where you've passed it a null. Okay, so if I've got a sample line here, this is the sample line. Well, let's quickly go through the classes. We've got three classes. Fleet, which is sort of a topmost class, it's a container. Inside it there's an array of cars, and there's the car class. Inside the car class there's another class called dimension, and that class is which has got a width, height, and a length. Okay, so we've got these three classes that basically they reside inside each other. So fleet is sort of a big class. Inside fleet there's cars, which is an array, so it's lots of cars. And inside each car there's a dimension, and inside the dimension is a width, a height, and a length. Okay. And this line here is basically that sort of structure. So if I have a line like this in my code, and I get a null pointer exception on that line, so this line is the top of the stack trace, then on this line there's actually 5 possible causes of the null pointer exception. Even though it's just one line, 5 possible. 3 of them falls in the first category, and also note the word before. A lot of you guys also get it wrong. It's before the dot. So you look at the whole line, from the beginning to the end, you find all the dots. There's a dot there, and there. So if you get a null pointer on this line, you have to look at everything before the dot. Okay, so the first dot will be that one. So that means fleet might be null. Possible. Next dot is that one. Everything in front of it, fleet.cars0 might be null. The last one is that dot there, which means fleet.cars bracket 0.dim might be null. Obviously, the only thing is actually null is the thing in front of it. Okay, so let's say that is the cause of the null pointer. That means the dim is null. That means the rest is actually fine. It's just the dim that's null. But you don't actually know this. It's not possible to know this. With JavaScript, it's a lot easier because JavaScript will actually tell you that dim is null. But in Java, it doesn't. Java will just tell you there's a null pointer exception on that line, and you have to figure it out for yourself. Another place on this line which can cause a null pointer is before a square opening bracket. So So that's that one. Square opening bracket, which is there, before it. That means cause might be null. Okay. Last one, which doesn't happen a lot, so you're going to find this one every now and then. In our wrapper methods, you find this one a lot, especially in the caches. Because the caches returns a wrapper long, but you want to return a primitive long. So when it casts from a wrapper to a primitive, you're going to get that error. Okay, so I'm just quickly going to explain the wrapper and primitive. You obviously get your primitive types. I actually made a list here. These are the primitive types. Boolean, byte, short, int, long, double, float, char. These are the types that start with a lowercase letter. You see all of these. Boolean, byte, short, the I, the L, the D, the F, the C. They start with lowercase. That means they are primitive types. Okay? They are not objects. They are not wrappers. They're primitive types. They can't be null. It's impossible for them to be null. Okay? Because they're not appointed to some location. They are the location. Okay? So the closest thing to null that you might get is possibly, a 0. Or let's say like a double. I think double can be NaN, not a number. So the closest thing to null you can emulate, but it will never throw an error. Okay. Well, let's hope it's still recording. So what? Where was I? Oh yeah. For each of these primitives, obviously because they're not objects, Java loses a lot of functionality. For instance, you can't use a hash map and put double as a key to the hash map. You can't do that. Java doesn't allow it because they are primitives. They're not objects with all sorts of weird methods and stuff like that. None of these have methods inside them. But so if you want to put this in, let's say, a hash map as a key, Java has provided us with wrappers. Wrappers is exactly the same thing, except the first letter is a capital letter. Okay. So you get Boolean with a capital B. That is the wrapper type of the primitive. It's an object. It's not primitive anymore, it's an object. It's a class. There's actually a class Boolean there, if you use the capital one. And Java auto-casts between them. So if it sees that you want to, in this case, you'll see here in dimension, this width variable here is actually a capital I for int. Oh shit, I think that's actually integer, not int. I'll fix that. So integer width. And here, you see this is a lowercase int. So with Java, this expression is valid, even though this is a wrapper and this is a primitive. But width actually can be null. Because it's a wrapper, it's an object, it can be null. A primitive can't be null, it's impossible. So then you would get a null pointer exception on this line as well. So basically the equal sign causes the null pointer exception. This one can be very tricky to spot. Sometimes you can pull your hair out, you can't understand why this thing's breaking because you do the null checks and everything's fine. Okay, so that's the last one here. From wrapper to primitive casting. Here's a quick example. I've got a wrapper long, y equals null, and then I've got a primitive long x, and it's equal to y. Then I'll actually get a null pointer exception on that line. Okay, so those are the three possible null pointer exceptions. I'm just quickly going to go through this. So that basically explains why, this is sort of part one, why we get null pointer exceptions, and the three possible places to look to find what is actually causing the null pointer exception. Okay, so what we want to do now is we need to circumvent null pointer exceptions. We need to avoid them. So we need to check that null pointer exceptions doesn't happen. And if there is a null, what do? Where do you go from there? This is just something I noted down. Any method in Java can possibly return null. Any method. If it's a method that you've written, if it's a method that some other code has written, if it's a library that you've downloaded, if it's Java native library, like let's say toString on a hash map, it can possibly return null. It is possible. So technically, actually, any method you call, you sort of have to do null pointer handling after that to make sure that there's no null pointer. Obviously, that's only true if it's not a primitive. So this rule only counts except if it's a primitive, then obviously it can't return null anyway. The methods can be these methods you're calling. They can, obviously, the way you code the method can make it impossible for this method to return null. That's true, and that's good coding. Obviously, the documentation just needs to support that. So each method can have its documentation, and the documentation can say this method will never return null. And then you can sort of assume that it won't return null. But the problem in this world is we have humans, okay? And humans make mistakes. So maybe you coded a method, you put your documentation there, you say, cool, this method will never return null. It might return an empty result, but it will never be null, okay? And you put it in the documentation, everything's fine. Everybody that uses that method saw the documentation, and they assumed it will never be null, so they never did any null checks. Now you come along, and you've got a new task, you need to edit that method, but you don't read the documentation. You just go and you edit stuff, and now suddenly you return a null. Now everybody else's stuff that uses this method is going to break. They never did any null checking. Okay, so yes, you can argue and say that when a method is written, there should be documentation and must always follow documentation. It was never ever change, because that's how it works. But in reality, as we sit here now today, and lots of people working on the same project, we've got newbies, we've got experienced coders, these problems are going to creep in. It's guaranteed. You're never going to circumvent them. They're always going to be there. Doesn't matter what says about rules of coding, you're going to get it. So you might as well code around it. Okay. So if you ever call another method, if it's a private method, I would say it will happen a little bit less, because obviously the method is right there, and you know nobody else will call them, so it's in the same class. So it's sort of a bit more protected. So you can see that the method, if it doesn't return null, it will probably never return null. But whenever you call any other method, you must first do a null check. And there's two ways you can do that. Wait, before I carry on, I just want to see what I did here. Yeah, that's basically what I said here. If it's impossible for a method to return null because of how it's coded, okay, it might change in the future to actually return null. So when you call the method, you still need to cater for nulls, because it might change. Even though it's not supposed to, it might. Nulls obviously needs to be detected and handled accordingly. Sometimes if you call a method and the method returns null, you can say, cool, no objects was found. The data was not found. You can just print on a message, it was not found. Or you can actually throw an exception. If that method isn't supposed to return null, you can actually throw an exception. But instead of just throwing a null pointer exception, you can actually give a reason to say that, hey, fleet was null, or cars was null, or there was an invalid dimension in this car. You see, then at least if it occurs online or in an app, or if it gets printed to a log, it actually tells you exactly what the problem is. So the fix is going to be easy. You don't have to sit and try and emulate it on our local environment or anything like that. It actually tells exactly where the problem is. Okay. Oh yeah, this one's also very important. A lot of people also miss this. If a method returns an object, okay, but this object actually contains other objects, and one of those objects might even contain more objects, you can't just check the smallest object if it's null. You have to check the big one first, then the one that's inside it, and then the one that's inside that. You have to check all the levels. If you just check the inside one, your if statement will actually return a null. I've seen that a lot, where people say, if, let's say, fpalm.item is unequal to null. then you actually get a null pointer on that line. That means if pom was null. So you've just checked the item inside. You must actually say if pom is unequal to null and if pom.item is unequal to null. Then you do the full checking. Check the outside object as well as the inner objects. Okay, so I've just sort of drawn this. I know it looks quite messy. It's supposed to be quite messy because it can usually get messy. But this is just to sort of symbolize how objects can be placed inside one another and how object hierarchy can look. Obviously, in reality, technically objects is not inside one another. They just reference one another. But just for this explanation and to compare it to the real world, basically the outside one is an object, and inside it there's 1, 2, 3, 4 other objects. You can compare it to this one. Fleet might be the outside one, and yeah, maybe that one would be cars. This one is the inner object. That one. Inside cars, you might have 2 cars, which is an array. Remember, actually, there's two levels there. Eh? Because it's an array, there's actually 2 levels. There's the array, and then every element inside the array. So even if you glance at it, there's only one declaration. But there's actually two substructures there. One's the array, and inside the array is each element. Okay, so yeah, might have cars inside that, and then may have a dimension, which might be that little circle there. And inside the dimension, you have width, height, and length, which is the small dots inside there. So they sort of cascade into one another. So yeah, I just need to check all those levels. Let's see. Yes, okay, let's move on to these 2. That is after you call a method now. Whether it's your own method, or someone else's method, whether it's a stub call somewhere, whether it's a web service, whether it's a Java native method, whether it's a method in a library, any method you call. Obviously, if it returns a non-primitive type, not one of these, then whatever result you get back, you need to do null checks on that result. And there's 2 ways to do it. Okay? I've just sort of made up names. I don't know, maybe it's worth Googling to see if you can find official names for these 2. There might even be other ways of null checking, but these are the 2 most popular ones that I found works pretty good. And the first one is explicit fault finding. This is the recommended one. The only problem is it's a lot of code. This is where you check each dimension, or each sort of object level, if you want to call it. So you first check the outside one, then you check the inside one, and then the one inside that, and then the one inside that. So the first one, we check the outside one. We check if fleet is null, because that's the bigger one. If it's null, we actually throw an exception. We say fleet is null. If fleet.cars is null, we say cars is null. And then you'll see this line here. It just gets longer and longer and longer as we go down. So we check every level to make sure that everything is valid. And we obviously display the appropriate message. Like I say, this is a lot of code and it's very extensive checking. But if there is an error in the future, let's say somebody modifies this getFleet method that actually returns the fleet, and they actually mess up, at least, yeah, you'll get a proper error to say what it messed up. And it'll be very quick to fix. You'll know exactly where to go and look for the error. You don't have to put in debugs and try and re-emulate an environment to find out where in this whole thing is the actual null. And obviously after all this, yeah, you can put your code of what to actually do. So the code that you do below all these ifs, because they all throw exceptions, will obviously jump out of this method and throw an exception in your upper levels. Below this, you technically have 100% valid data that won't throw any null pointer exceptions. Okay. So this is the one way. Does everyone understand that? Then the next way is the quick validation check. I use this one also quite a lot, especially if you don't want to code like all this all the time. Especially if you are on sort of if you're getting a lot of data from a lot of sources and you're building one massive data set and stuff like that, this is going to be very messy. Then I sometimes just use this just for a quick check, because sometimes data isn't important. Let's say you want to get, I don't know, a user surname from an ID. So you do a call to get a user's detail and there's no surname. You don't really want to throw an exception. You can just skip it. You can just not include a surname in the result. You still have a name, you still have the username, so you don't have to actually throw an exception, print it in a log somewhere. It's almost the difference between an error and a warning. This is sort of more just a warning to say, it is a problem, but I can actually continue. This is more like, it's a problem, we can't continue. There's no way we can actually do what we're supposed to do because, yeah, we don't have sufficient data. So what we do here basically is we just check, we actually do the same. We check each and every level. So we check the outside one, the inside one, the one inside that, the smaller one, and the small ones. We just don't throw exceptions, and we do it in a one-liner. So this from here to here is actually one line. I've just obviously new-lined it to make it a bit easier to read. But first, I check if fleet is unequal to null. Then I check if fleet.cars is unequal to null. Then I actually check if the cars array is bigger than null. So this is just to avoid a array index out of bounds exception. Then we check if that actual element inside the array is unequal to null. Then we check if dimension is unequal to null. Then we check if the width is unequal to null. Then, I just said do here, this is where you can do whatever you have to do with this data. But then at least you know this data is legit. You can actually carry on. Okay. Where we've recently obviously found an issue where this was not done is on the extra data on lists, on the list search. When we get a F list from somewhere, sometimes there's extra data attached, sometimes it's not. But remember, this extra data is in the field called, I think it's called extra data. It's a hash map. This field can actually be null. So you can't just say list.extradata.get this. You actually have to check if list.extraItems is unequal to null. And you might even include a check to say if list.extraItems is not empty. I like to do that as well. Just to, I mean, if you get an empty list from somewhere, it's actually pointless doing anything further because you know it's empty. So you might as well check for that as well. So I would use this if, for instance, and I would say if list.extradata is unequal to null and list.extradata or not list.extradata dot is empty. So then we make sure it's not empty and it's not null, and then we can carry on. Okay. Yeah, that basically covers the whole null pointer checking. How to understand null pointers, to read them. How to obviously cater for them, and what to do after them. If you did detect one, what to do next. Does everyone understand? Does anybody have any questions? No one? Okay, cool, awesome. Yeah, let me just think. Yeah, just quickly, I think I just want to explain what actual null pointer is. Yeah. Okay, this is sort of a quick afterthought to understand what a null pointer actually means. If you declare a variable in Java, let's say like fleet, for instance, that is actually not, if you just do that and you just put a semicolon there, it's not equal. You just do that, semicolon, that's it. Nothing else. What it actually does behind the scenes, inside Java, it actually allocates memory, but it only allocates, I think, I might be wrong, 8 bytes, okay, which is 64 bits. That's all it allocates. And it actually, and that 8 bytes is called a pointer. Now in that 8 bytes, it makes all of them 0, 0, 0, 0, 0, 0, 0. That 8 bytes points to another memory location. So that's where the word pointer comes in. It's an address of a memory location in RAM. So those are the 8 bytes. Obviously you add them together to form one massive number, and that points to a memory location. So if you say this, actually what happens there, let's say you say, if you say this thing will obviously return an object. But this thing doesn't actually return the data. It only returns an address of the data where it's stored, those 8 bytes. And then it just actually updates this thing address, that 8 bytes, it just sets it to where the actual data is. So this return of this function will actually be very quick, because only 8 bytes it goes back. It doesn't actually make a copy of the data and pushes the copy back. It leaves the data where it is, it just tells this fleet pointer, oh, this is where the data is. So that's why they say null pointer. That's where the word null pointer comes from. You're trying to access something, you're trying to access that pointer's data, but the pointer's not set yet. All the bytes are 0. So then it's like, well, I don't know where you want to go with this data, because this thing doesn't point to actual data. Then you get a null pointer exception. So yeah, obviously fleet needs to point to this thing. This thing actually sits in memory somewhere. And this thing might be 50 kilobytes big. But the fleet variable points to that location where all this data is sitting. So obviously if it's not set and you try to do operations, so say fleet.cars, you're actually saying, go to that memory location and find another pointer in there, which is also 8 bytes big, with the name cars, and they go into it. But obviously, because the original fleet variable is null, the bytes are all null of the address location. It doesn't know where to go next, where to find the memory. So that's where null pointer exceptions comes from. Okay, cool. Everyone happy? Awesome.